Hello friends, I am Praveen Thakre, professor in Zeal College of Engineering and Research, Pune. Today, in this video, we are going to study the fundamental tool of calculus, which is highly used in almost all programs of engineering. The daily life example I am giving, if you are coming to college by your own vehicle and there are various factors, or you can say the variables, you can say the parameters. If time is the parameter, speed is the parameter, and the traffic density is the parameter. And if we consider these three parameters, and I have taken time t is a function of speed and the traffic density. Time is a function of speed and the traffic density. And what I am going to do, I am going to fix this traffic density. I am going to keep traffic density constant, and I want the rate of change in time with respect to speed. As speed changes, time may reduce. Speed decreases, then time increases. But if I want to calculate the rate of change in t time with respect to s, in this case, the tool is being used, which we are going to study. The prerequisite of the tool is limit and derivative. In short, everybody is aware of these two concepts, limits and derivative. The limit is what? The limit of any function, LT I am using for limit. Limit of any function, is equal to L. It's what? Limit of this f of xy function with respect to L when this xy tends to AB. xy in general a point in xy frame, and AB are the coordinates of the point. This represents a single point which is a constant point, which is fixed point in xy frame, and this xy approaches to AB. This xy approaches to AB, and when this approaches to AB, the value of the function is L. This is what called the limit. This is limit. Now, what is derivative? In earlier years, you might have gone through derivatives. Graphically, I tell you first. The derivative is what? Derivative represent slope of the tangent. This x and y axis. Slope derivative represent the slope of tangent. So this is the curve. And this point I am going to take, and this is the tangent to this point. Let this point be P. The slope of the tangent is what? Derivative of this function. Y is equal to fx is a function, suppose. The derivative of y is equal to what? It is the slope of the tangent. Slope of the tangent is represented by the derivative of this curve at this point. Now this x and y axis. If I take a horizontal line, the slope of the horizontal line is not there. Means the slope is 0. The slope of the horizontal line is what? 0. Because that line has no slope. In horizontal line, y remains constant and x being varied. When y is constant and you know that the derivative of the constant is 0, the slope of the tangent of horizontal line is 0. Now, so this curve I am going to draw, this one. And at these 2 points, point P and point Q. Okay, these 2 points are very closer to each other. The coordinates of the points are xy. And coordinates of this point, the x delta x plus y delta y. What is delta x and delta y? It is delta x is a small increment in x and delta y is a small increment in y. With this much distance, this much distance is very less. Now, this much distance is y plus delta y. This much distance is y, therefore, this much distance is this one, is y plus delta y. Okay, this is y, this is delta y. Okay, and this is x, and this is x plus delta x. So this much is delta x. Okay, and what I am going to do, I am going to take the ratio of these two, ratio of delta y, and delta x, and the limiting value, of this ratio when delta x becomes 0, means delta x becomes negligible. So this is what called the derivative of y with respect to x. This is derivative of this curve y with respect to x. This curve is y is equal to fx. The derivative of this curve at the point P is what? dy by dx is. Now, derivative. How to calculate derivative of x square? Here I am writing find the derivative of x square. Okay. Let y is a function of x, means y is equal to x square, and the derivative of x square is 2x, everybody knows. But what I am going to explain the definition of the derivative. I will be using definition of the derivative here. The definition of the derivative I write, limit as h tends to 0, f of x plus h minus fx, this divided by h, and this is what? This is derivative of fx with respect to x, and I am denoting it by f dash. F dash of fx means what? It is derivative of fx with respect to x. Now y is equal to x square, it is known to you. Then f of x plus h means f of x is x square. Y is equal to fx, f of x is x square. The f of x plus h is what? X plus h whole square. The value of f of x plus h I am putting, that is f of x plus h whole square minus fx is x square, this divided by h. Now when you open the brackets, just I am going to open it, this is x square plus 2xh a plus b whole square formula, a square plus 2ab plus b square plus h square minus x square, this divided by h. Now this x square gets cancelled and 2xh divided by h and h square divided by h I am writing here, limit h tends to 0, 2xh divided by h means 2x, plus h square divided by h is h. Now put h equal to 0, so you are getting 2x here. So in this way, we found derivative of y with respect to x. In this way, we found derivative of x square with respect to x, where y is equal to x square. Okay, the definition of the derivative now, I think it is clear to you. This point is xy. The coordinates of this point x plus h and y plus h. Okay. Then this much distance is x. This much distance from the origin is x plus h, means this is h1. This is h1. And this is y plus h, and this much is y. Therefore, this much distance is h again. Okay. Now the f of x, function of x plus h minus of fx divided by h, and its limiting value when h decreases to 0, when h is approaching to 0. Okay, that is what called the derivative of fx with respect to x. Derivative of fx with respect to x. And here we have calculated the derivative of x square with respect to x using definition. Now, so we are talking about the important or fundamental tool which is being used in almost all programs of engineering, but that I didn't tell you. What is that tool? The tool is what? Tool is the derivative tool. But where one variable will be acting as a variable and other variable will be kept as constant. So I am talking about the partial derivative now. So what is partial derivative? If y is a function of several variables, and derivative of y with respect to one of those variables keeping other variables constant. Derivative of y with respect to one of those variables keeping other variables constant, that is what called the partial derivative. That is what called the partial derivative. Now, the definition of partial derivative I tell you. We started discussing partial derivative. Now, what is the partial derivative? It is the derivative of a function of several variables. It is the derivative of the function of several variables with respect to one of those variables, keeping other variables constant. This is partial derivative. Partial derivative is nothing but the derivative, but it is the derivative of function of several variables with respect to one of those variables keeping other variables constant. So we started partial derivatives. The partial derivatives are highly used in mechanical engineering, in heat one-dimensional, two-dimensional heat flow problem, in electronics and telecommunication, in image processing it is widely used, in chemical engineering also, in while calculating the rate of reaction, in chemical engineering it is highly used, in computer and information technology the partial derivative is used while calculating the rate of downloading data, in electrical engineering, in electronics engineering. This is used in each and every program of engineering, almost all the programs of engineering. Thank you very much.